Okay, this video is going to be a repeat of what we did in class today. This is the second half of elimination. Mostly I'm making this video for the people that were on the field trip for biology, because when you are absent, especially when you when you choose to go on a field trip and you're gone, you are still responsible for your assignments and for getting them done. So, this video is meant to help you. No excuses. So, due to obvious reasons with my voice, I'm probably only going to get through 2 of these. But hopefully 2 will be enough and you can keep going. All 16 are due tomorrow, okay? So let's start from the beginning. All right. Number 1. There we go. All right, number 1 says x minus 2y equals 12, and 5x plus 3y equals negative 44. So sorry. Okay. So when we're doing elimination, the whole point of elimination is to get rid of one of your variables. And to do that, one of the variables has to have the same number. In this example, as you can tell, none of them do. So the easiest way to go about this is to somehow make this x have a 5 right here, okay? So right now it's just a 1. That's a horrible looking 1. There you go. So what we're going to do is we're going to multiply the top equation by 5, because 1 times 5 is going to give us 5x. So you have to do it to the entire equation. You can't just multiply the x times 5, because then you're changing the equation and it's not the same thing anymore. So we're going to distribute the 5. So 5x minus 10y equals 60. And then the bottom equation, we are not changing at all. So rewrite it. And at this point, now you have the same number on your axis, and you can eliminate. Same signs, subtract. 5x minus 5x. This eliminates. Negative 10 minus 3. It's going to be negative 13. And then 60 minus negative, so adding 44 is 104. Divide that by negative 13 and you get negative 8. So there's y. Now you're going to take negative 8 and plug it into one of the original equations. I'll go with this top one. So x minus 2y, which is negative 8, equals 12. Okay, so as an ordered pair, answer right there. And number 2, okay, so once again, the point is to have the same number on one of the variables. Now, I want you to realize you could, if you wanted to, make the x's have the same number. But for 7 and 4, hold on one second. For 7 and 4, to find a common number, it would be 28, because that's your least common multiple between these two numbers. So instead of changing both equations to have 28x, it's way easier to change this so that these are both 2y. So the way we're going to do that is multiply the bottom one by 2. Wow, my voice is bad. All right, 7x minus 2y equals 37. Leave the top one alone. The bottom one becomes 8x plus 2y equals 38. We are trying to eliminate the y's, so we're going to add because one's negative, one's positive. Different signs means we're going to add. That was bad. So 7 and 8x is 15. 37 plus 38 is 75. So x equals 5. Now you're going to plug that into one of the originals. I'm going to go with this one. 4x plus y equals 19. Okay, oops. So as an ordered pair. There you go. All right, so that's the first two problems of assignment number 42.